Hello there and welcome to my YouTube channel. This is your friend and teacher Kaunga Samuel. Those of you who are new to my channel, please consider subscribing. Okay, your subscription will go a long way in really growing this channel. Okay, without wasting much of our time, let's just jump into the lesson of the day. As you can see from your screen there, today we're just going to look at linear programming. Linear programming. Now, as you look at linear programming, there are certain things that are very cardinal, very important for you to consider, to put into considerations. Okay, what are these key things? You need to associate symbols to their correct lines. So here we're going to say, okay, key things to consider. Okay, so key points to consider okay. 1, relate or associate each symbol to its correct line. Okay, there are two types of lines. There is either a dotted or a solid line. Okay, this is one key important thing that you need to know. That simply means that if the symbol the symbols less than or greater than are used, then the line will be dotted. Okay, the line will be dotted. Okay, like so. The line will be dotted like so. So we're going to have a dotted line like that. Okay, so that simply means we have a dotted line, as you can see there. Now, if the symbol if the symbols are equal to, greater than or equal to, or less than or equal to are used, then the line will be solid, like so. Okay, we're going to have a solid line like so. Okay, so that is it. This is very important as you look at linear programming. This is very important. Next, the other important thing that you have to consider is that, okay, let's just jump into another page. The other important thing that you need to consider is this. If this is your X or Y plane, okay, if this is your X or Y plane, okay, if that is your X or Y plane, x and y, and we have numbers here 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. These are negatives. And there's a 0 there. Okay? One thing that you must consider now is that is the lines. Okay? The line. You need to consider the lines involved. Okay? If this line passes here, okay, at x is equal to 2 here, if we have a line there, okay, now this line has got two sides. Okay, this line has got two sides. This side here, this side on the right side there, we are saying we are going to have on this side we're saying it is the greater part of the line. Then this side is the lesser part of the line. So this line has got two sides. It has got a greater part and the lesser part. So this here, when we go like this, okay, we're going to have the greater part, then here we are going to have a lesser part. When we go like that, we have a greater part. As we go like this, we have a lesser part. So that simply means here I'll read this line. If this is my x, okay, if this is my x, I'm going to say, okay, when I'm going to my left side, I'm going to have x is less, okay, than or equal to 2. On the greater part, I'm going to have x is greater than or equal to 2, like that. Okay, very, very important. Now, straight away, let's just jump into exam questions and see how we can attempt exam questions. By the way, in your exam, you always look out for lines that are standing vertical or horizontal. Start with those. Okay, so now let's just jump into exam questions. Okay, exam questions, ECZ exam questions. Let's look at this question there. Let me see the questions we can start with. Let's start with this question here. Okay, let's just start with that question there. Write the 4 inequalities that define the unshaded region R in the diagram below. Okay, write the 4 inequalities describing the shaded region R in the diagram below. So here I'll say, okay, look out for those that are vertical. So like so, this one. Have you seen? Have you seen this one? It is passing at x is equal to 4. Have you seen the other one? It is here. These are the lines you have to look out for. The other one is here. These are the lines, the first lines that you have to look out for. Great. After that is done, then now you can consider this line. Okay, so straight away, let's look at the solutions to this question. Here are the solutions. Solutions. Okay, I do like that. So my first line, okay, my first line is this. Look at this. Look at this line here. This line passes at x. X is equal to -2. Okay, x is equal to -2. That's where this line is passing at x is equal to -2. Now consider which side of the line is the clear region. Here we are interested in the clear region, just the clear region. Which side of the line is the clear region line? So it is lying on the greater part. This is the greater part. This is the lesser part. Remember, this is the greater part. this is the lesser part. So the clear region is lying on here on the greater part. So for this line, I'm going to say, okay, the solution is going to give me x, okay. Since this is a solid line, so I'm going to say x is greater, okay. X is greater or equal to -2. Okay, x is greater or equal to -2. That is my first line. My second inequality is going to be, look at this line here, this line, okay. Now this is x is equal to 4. X is equal to 4. Now check, where is the clear region lying? Okay, which side of this line is the clear region lying? So the clear region there is simply lying on the lesser part, there. Okay, it is lying on the lesser part. So what we're going to do here, we are simply going to say, okay, x is less or equal to 4. That is your second inequality. Okay, your third inequality is this one here. Look at this one. Have you seen this line? This line here, we are simply saying, look, if you are also observant, this is 2. Okay, this is 2. Now, which side of this line here, the y line, y is equal to 2, which side of this line is the clear region R found? So you find that R is found on the upper side, meaning we're saying y is greater. So here we're going to say, okay, y is greater, okay, than 2. Y is greater than 2. Can you see that? Why are we saying y is greater than 2? Take note of the line. The line there is dotted. Okay? The line there is dotted. Now, the last one is this equation there. Okay? I mean this line here. Look at this line. This line here. This is going to be our last line. Can you see that? So what we are going to do here is to say, okay, here I'm going to use the certain techniques. I'm going to apply certain techniques for me to solve this. What I'm going to say is to say, okay, I'll say y. Okay, let me do it from this side. I'll simply say the first thing is to find the gradient. I'll say, okay, I have the point 0. I'll pick this point here. This point is 0,6. Okay, so I have 0,6, and I have this point here is 8,0. So I have 8,0. Okay, so I'll call this as my x1, x2, y1, y2, and then I'll say, okay, m is equal to y2 minus y1 over x2 minus x1. So this is going to give me m is equal to, my y2 is 0, 0 minus 6 over my x2 is now going to give me, my x2 is going to give me 8 minus 0. So at the end of the day, we are going to say, okay, m, therefore m is equal to -6 over 8. So 2 there, we're going to say, okay, -3 over 4. That is your m. Therefore, that being my m, I'll jump this to, let's come to this other region there. So I'll simply say, okay, if that is my m, then we can say, therefore, using this, y is equal to mx plus c. Okay, using that, you can see that here I have my y-intercept just here at 6. Okay, my y-intercept is where? Is here at 6. So I'll simply say, okay, y is equal to, my m is negative 3 over 4x plus 6. Okay, now where am I going to shade? Now take note, where is the clear region lying? The clear region, take note, the clear region is lying on the downside of this line, on the downside. That simply means we are going to say y is less. The clear region is on the downside. Can you see that? It is here on the downside. So meaning here we're going to say, therefore, the required inequality is going to be y. Therefore, the required inequality is going to be y is less. Okay, y is less. Let me just write it nicely there so we are able to see it. So y is less. Okay, therefore y is less than or equal to negative 3 over 4 plus 6. Like that. This is going to be your solution. I hope this is making sense and it is adding value, okay, to your revisions. That's great. Okay, next question. Next question. Let's look at this one here as our next question. Exam question. Let's look at this one there. Okay, let's consider that one. Now, write 3 inequalities that define the unshaded region. So in your mind, just have the unshaded region. Now, for this one, we're going to say, okay, solution. Let's have our solution here. Solution. So we say, okay, which line can we start with? We'll start with this one. Can you see this one? This vertical line there, it is passing at x is equal to 2 here. At x is equal to 2. Now take note, this is a dotted line, meaning the symbol to be used is not going to have the O equal to, no. So we're going to say, okay, where in this line has got 2 sides. Which side is the clear region lying? On the greater side or the lesser side? You find that it is lying here on the greater side. So we'll simply say, okay, the equation there is going to give us x is greater, okay, greater than 2. That is your first inequality, greater than 2. Your x is greater than 2. That is where the clear region is lying. It is lying on the greater side. Very simple indeed. Now, where is the clear region lying? In this line. In this line. So we go to this line and that line. Now, one thing that is worthy taking note here is that when you look at this line here, okay, this line, in this line, we are saying y is equal to 8. This is 0,8. If you're so observant, 0,8, meaning the y-intercept there, okay, is 8. Our c is going to be 8, okay, and here we've got at this point 6,4. So we can find the gradient there. We'll say, okay, m. So I'm at 0,8. I'm at 0,8. Okay. So m is going to give me. So here I'll say I can either, so the points that I have is 0,8 and 6,4. 6,4. So here I can say this is my x1, y1, x2, y2. Then I can plug these guys into the formula. So I'm going to have y2 minus y1 over x2 minus x1. So this is going to give me y2 is 4 minus y1 is 8 over x2 is 6 minus x1, 0. So now I'm going to have negative 4 over 6, which is going to give me 2 there, okay, which is going to give me 2 there, okay. I'm going to have negative 2 over 3, like that. So this is my m, okay, that is my value for m. Now here I'll say, okay, if this is my value for m, therefore I know my intercept there, my y-intercept is 8. Y-intercept here is 8. So I'm going to say, okay, since y-intercept is 8, I'll simply say, okay, y, we're going to use the equation y is equal to mx plus c. So I'll say y is equal to, what is my mx plus c? So my m is now negative 2 over 3 plus 8, okay, plus 8. Now take note, the clear region in this line, the clear region is lying on the lesser side of y, the lesser side of y. So I'll simply say, therefore y is less or equal to negative 2 over 3 plus 8. This is my next inequality. Okay, so you can rewind the video. I'll clear this work just to create some space. So here I'll clear, okay, to create space. Let's just clear that. Oops, there's a mess there. So let's do that. Okay, and create space. So meaning my next inequality is going to be brought here, y less or equal to negative 2 over 3 plus 8, okay, plus 8, like that. You even underline. Okay, the last one now, we're going to say, okay, for the last one, the process is going to be the same. So here I'm saying, okay, I'm going to have this here will be my m1. So my m1, I'll pick it up from here. Take note, from this point there. Okay, there I'm going to have, this is 2. So I'm going to say this is 2, 0. And this is 6, 4. Okay, this point here, 6, 4. So I'm going to call this as my x1, y1. Here I'll say this is my x2, y2. Okay, so to find the value for m there, I'll simply say, okay, m, therefore m is going to give me y2 minus y1 over x2 minus x1. Okay, that there. So I'm going to fuse in the numbers. So I'm going to say, okay, y2 is 4. So 4 minus 0 over, that is going to give me 6 minus 2, 6 minus 2. So m is now going to give me 4 over 4. So m is going to give me 1. Okay, my m is 1. Now since my m is 1 and I don't know exactly here, I don't know exactly where the line is cutting the y-axis, so I'll rely on the equation, the 1-point form of the equation, and it goes like this. So I'll say, therefore I have the gradient. So I'll say, using y minus y1 is equal to m x minus x1. So I'll get any of my points, either this point there, okay, this point here, or that point there can work. So I'll simply get 2, 0, okay, I'll simply get 2, 0 as my point, 2, 0 there as my point. So this is going to be x1, that is y1. So I'll simply say y minus 0 is equal to, now I have 1 there, multiply x minus 2 there. So this is going to give me y is equal to x minus 2. Now take note which side, okay, which side of the line is the clear region line. This side of the line, this side of the line. Take note, The clear region is on the upper side of this line, the upper side there. What is the meaning? That simply means we're going to have y. Okay, that simply means we are now going to say our required solution is going to be y, okay, is greater or equal to x minus 2, like that. So your solution, please, this is a video, you can rewind. Okay, so I'll clear this so that we can have room for our solutions. So this one I'll clear. So the solution there is going to give us a y is greater or equal to x minus 2. As simple as that. If you are liking this video so far, please don't hesitate to give it a thumbs up. Don't hesitate to invite your friend so that together we can grow this channel. All right, so from me, I think this has been long enough. From me, if you need more questions on linear programming, please drop your comment in the comment section. Let me know so that we can cover as many questions as possible. So from me, your friend and teacher, it's goodbye.